Now the first law, that is known as what? Coulomb's law of electric force. The force may be attractive in nature, the force may be repulsive in nature. It depends on the charges. Okay, so I think we have done in class 11 Newton's law of gravitation. It is somewhat related to that. The law is stated like that if there are two charges, the force between them must be directly proportional to the product of charges and inversely proportional to the square of distance between them. Suppose there are two charges, as you can see in the diagram, q1 and q2, and the distance between them is what? Small r. Then F must be proportional to q1 q2 and F must be proportional to 1 by r square. In a combined form, if we write it, we will write as F proportional to q1 q2 by r square. And we know now that to remove the proportion sign, we need to give a equal to sign and a constant. So F equals to k q1 q2 by r square. Here k is a constant that depends on the medium. Okay, later on k was replaced by 1 by 4 pi epsilon naught. You can see over here, this is 1 by 4 pi epsilon naught. The value of this is how much? 9 into 10 to the power 9 Newton meter square per coulomb square. What is epsilon naught over here? Epsilon naught, the meaning of epsilon is, this is epsilon naught. The meaning of epsilon is permittivity of the medium. Okay, if it is epsilon naught, it means permittivity of a free space, because it is not over there, 0. If it is only epsilon, it means the permittivity of some medium. So if we replace k in the above equation over here, then we will get what? F equals to 1 by 4 pi epsilon naught q1 q2 by r square. This is known as Coulomb's law. From this law only we can define charge also, the unit of charge. Suppose define 1 coulomb of charges. So what we will do in this equation only, if q1 and q2 are the two charges of 1 coulomb each, separated by a distance of 1 meter, then what will happen? q1 q2 equals to 1 coulomb, r equals to 1 meter, then F equals to what? 9 into 10 to the power 9 Newton. Then how we can define 1 coulomb of charge? 1 coulomb is that amount of charge that repels an equal and similar charge with a force of 9 into 10 to the power 9 Newton when placed by a distance of 1 meter. Okay, this is very simple. This question may come in the board examination that defined 1 coulomb of charge. Now 1 coulomb of charge, to define it, you will go through Coulomb's law only. Suppose if there are two charges of 1 coulomb each and separated by 1 meter apart, then the force between them will be 9 into 10 to the power 9 Newton. That's it. Okay. Now this is very important. Coulomb's law in vector form. Coulomb's law in vector form. This is too important for your examination. You can see over here we are going for the same topic, but this time we are going in the vector form. You can see there are two charges, plus q1 plus q2, separated by a distance r apart. As you know that these are like charges, plus plus, so there will be repulsion between them. So F12 and F21. Now what is F12 and F21? We have already discussed this thing in Newton's third law of motion, that F12 is what? The force on charge 1 due to charge 2. And what is F21? The force on charge 2 due to charge 1. Okay. What is R12 and R12 over here? The R12 is what? The position vector of charge 1 with respect to 2. R21 is what? The position vector of charge 2 with respect to 1. Okay. Now we will find F12 and F21 both. F21 1 by 4 pi epsilon naught q1 q2 by r square. It is similar as we did earlier now. Okay. But F21, you can see I have written over here R12, over that I have given a hat, arrow. This is what? R12 is unit vector. R12 is what? R12 vector divided by R. This already we have done in class 11 chapter vector. Similarly, what is F12? 1 by 4 pi epsilon naught Q1 Q2 by R square, that is R21 hat. Now at the time of F21 we are taking R12 hat. At the time of F12 we are taking R21 hat, because F21 is what? Charge, force on charge 2 because of charge 1, and R12 is what? R12 and F21 is coming in same direction, as you can see in the diagram, and F12 and R21 is coming in same direction, as you can see in the diagram. Okay, and the work of unit vector is to show direction only. That is why we have written F21 with R12 and F12 with R21, because the direction is same. Now in these two forces, what is the difference? The difference is between only the unit vector, but we know that the unit vectors are equal and they are opposite. R12 equals to minus R21 according to vector. So F12 is also equals to minus F21 and F21 equals to minus F12. Thus it obeys Newton's law of third motion, that is equal and opposite forces. But Coulomb's law holds in a good range, that is the distance between the two charges must be from at least 10 to the power minus 15 meter to a maximum of 10 to the power 18 meter. Okay, there are some limitation also of Coulomb's law. The first one is what? The charge must be at rest. It will not work for the charge in motion. It must be point charges. Okay, the separation must be between 10 to the power minus 15 to 10 to the power 18 meter. Outside this range, the Coulomb's law will not be valid. Okay, now dielectric force constant. As I told you, epsilon, we did not discuss about epsilon at that time very much. What is epsilon? Epsilon is known as permittivity. If it is epsilon naught, it is known as absolute permittivity, and if it is only epsilon, it is known as relative permittivity or dielectric constant. Suppose if you are going for force according to Coulomb's law, it becomes what? 1 by 4 pi epsilon naught Q1 Q2 by R square. If it is vacuum, we have written over here what? Epsilon naught. And this is question 1. And now we are going for equation 2. Suppose if it is a medium, we have written over here what? 1 by 4 pi epsilon Q1 Q2 by R square. Here you can see with epsilon there is no 0, there is no O. So because it is a permittivity of a medium, not of vacuum. Okay. Now we will do what? We will divide equation 1 by equation 2. What will get? F vacuum by F medium. Everything will cut. What will be there? Only epsilon by epsilon naught, which is known as equal to K. This K is known as dielectric constant. So if I tell you to define dielectric constant, how you are going to define it? The dielectric constant is a ratio of permittivity of a medium to the permittivity of the free space. And as it is a ratio of the same thing, there will be no unit for this. Okay, in the above equation we can see that F medium equals to what? F vacuum by K. So if you know when the two charges are placed in vacuum with the same distance, okay, if you want to find the force on those charges only when they will be placed in a medium, what you need to do? You need to divide the force on vacuum by the dielectric constant of the medium. Okay, and again, how you can define dielectric constant? The dielectric constant is nothing. It is you can define two ways, either in the ratio of force or in the ratio of permittivity. First, we are going to the ratio of force. The ratio of force between two charges when placed in a vacuum at a certain distance to the force of those two charges only placed for the same distance in a medium. Okay, or otherwise you can go for, it is simply the ratio of permittivity of a medium to the permittivity of free space. That's all for today.